Okay. Hello, Nanya.
Hi.
So, quick roll call. We have Ados, Nanya, Nikhil, Dheera, Jenna, Neil, Sarah, Tony, Riya, Ritika, Sahit, Samriti, and Vipan. Couple of kids are missing. Davik is not here. Dale is not here. Salanya. So, anyways, we'll get started and we'll see whenever they join how do we catch up. So, we have started with the unit problem solving and data analysis. Hi Dave. So, as I mentioned in the previous class, this unit has no new concept that we will learn. We will actually look at three key elements. One is data collection, data analysis, and then data representation. So that is where we start talking about the basic concepts around percentage, mean, median, mode, and then we'll look at some more practice problem that we'll deal with, and then we'll go into the data representation part of it. That is where we'll look at different tools and tools, be it any kind of graph, charts. And again, my only request to you all would be, don't look at these tools or platforms only as something to draw. There are a lot of hidden information inside it that we have to decode. That's the main purpose of this whole unit or the techniques that we learn. Hello, Saranya. So the way I have structured the rest of the classes for this particular unit is, today we will again look at some of those problems that relating to the concept that we have learned so far, and then we'll see how do we get started with some of those tools that we use for data representation. So we are still in the first two phases of this unit where we are talking about data collection and data analysis, and then we'll go to the next part of it, that will be data representation. And for all of you to be very comfortable with this unit, you would need to start having that eyesight of poking inside the data to derive some conclusion out of it. Okay, so that will be all about what we'll do in this unit. Any questions before I get started? No questions. Tony, are you okay? Ritika okay? Arush okay? Everybody okay? Okay. So silence means yes. I will say that I will get $500 from each one of you and nobody responds to it. That means I'll say yes. So I'll get 500 from everybody. No, I'm just kidding. You guys are my kids. I'm not going to take money from you all. But on a serious note, so just one information for you all before we start. Next weekend we are going to have classes. So you'll get some relief from me. I've been torturing you guys continuously every weekend. So that gives you a week to unwind yourself and spend some time with family and your loved ones. And then we'll resume the week following that. So in the whole year, if you see, there are only 2 holidays that I give you guys and I keep it for myself. One is Thanksgiving, one is Christmas. And the reason why we are looking at these 2 holidays, because this is when you get break in your school also, and most of the families plan for some travel, some get-togethers and all that. So that's why I'm planning not to take classes next weekend. I can take classes on Saturday, but I'm just giving it back to you guys so that you can use that time to unwind and stay away from thing called studies. Okay, just for a week. So let's get started. So I think some kids are missing. Some kids have started enjoying Thanksgiving break already. Yashmita is not here, but we'll get started. Khushi is also not here. So let's look at some of the problems that I have flashed for you guys. So what I'll do is I'll put a table here, and again, if you guys are expecting that I'll teach you guys something, trust me, I'm not. I'm not going to teach you anything new. We are going to deal with this unit, look at some of the different types of problems and put some strategy around it to be able to solve or deal with these problems with ease. That will be our goal. Yeah. So somebody joined between, that was Biswa. Yeah, Biswa was also missing. So Biswa, just for you to be aware, we are continuing with our journey with the unit data analytics and problem solving. So we are going to look at some more problems. We talked about mean, median, mode yesterday, and we'll look at some of the word problems that comes around it, and then see how do we approach to solve those problems. Yeah. So here's the question. So I have certain things in the form of a table. Crop A, B, C, D, E, and then yield in terms of kilogram per hectare. Okay, so this one crop A is 46,400, 75,000. This one is 75,000, 930. This one is 53,130. This one is 42,530. This is a table given as part of the problem. And then this question says, a farmer recorded the total fresh yield in kilograms per hectare, of several varieties of onion crops. So these are the different crops of onion, and this is the yield in terms of kilogram per hectare. Okay. The table gives the result, as you can see. If the farmer tried a new variety with a 57,930 kilogram per hectare yield, how would it affect the median and mean of the crop yields? Let me repeat the question for you all to digest and process this. There is a table given here. I'm not reading the numbers here. The question says, a farmer recorded the total fresh yield in kilograms per hectare of several varieties of onion crops. So all these varieties A, B, C, D, E that you see, these are the different varieties of onion crops, and the yield in terms of kilograms per hectare. Hello, Kushi.
Hi.
So Kushi, you are late by 10 minutes, but you have not lost anything so far. We just started with the first problem. Okay. So this is a table given to us, and this is a farmer has recorded the yield for different varieties of onion crop in terms of kilogram per hectare. Variety A 46,400 kilograms per hectare. Variety B 75,000 kilograms per hectare. Variety C 75,930 kilograms per hectare. Variety D 53,130 kilograms per hectare. Variety E 42,530 kilograms per hectare. Okay. If the farmer tried a new crop or new variety with a 57,930 kilograms per hectare, how would it affect the median and mean of the crop yield? That's the question. And then you have few options. Both the median and the mean will increase. Option A says median and both will increase. Okay. Option B says both median and mean will decrease. So median and mean decrease. I'm just using some short form as I'm feeling lazy after a heavy lunch. The median will decrease, but the mean will increase. So median will decrease, but mean will increase. Option D is median will increase, but mean will decrease. So just summarizing this question one last time before I let you guys deal with it. The table that you are seeing here, after whatever I have written here, okay, this represents the yield of different varieties of onion in terms of kilograms per hectare. So 46,400, 75,000, 75,900, 53,130 and 42,530. The other yield in terms of kilogram per hectare. And the farmer introduced a new crop with this yield, 57,930 kilogram per hectare. The question is, by adding this crop to this information, what would happen? First option given is mean and median both will increase. Second option is mean and median will decrease. Third option is mean will decrease, median will increase. Sorry, median will decrease, mean will increase. Fourth option is median will increase and mean will decrease. Now, everybody in this class knows how to calculate mean and median. I'm hoping that that's a fair statement. So, with that information in place, what would be your interpretation? And again, this problem doesn't need calculation. It just needs a thoughtful evaluation of the information and wrapping our head around this. Pranit, are you doing it, or you have come to a conclusion already?
Just need one thing.
Okay. So everybody heard the question. Neil, Sarah, Samriddhi, Saranya, Vivan, Tony, everybody, right? Ritika, Dheera, everybody just deal with it, okay? Let me know once you're ready to tell me your story. And again, there's nothing about finishing 50 problems. It's about doing one problem and being 200% sure about how we are wrapping our head around this. So Khushi, Ananya, you guys heard the question completely? Ready to deal with it? Khushi, how about you, beta? Heard the question or something is not clear yet? Khushi and Ria, both are okay? Okay. Okay. I'm going on mute. Sahit, Arush, go for it. Everybody, I'm just calling out some names randomly without being mindful of it. And you guys will have actually 2-3 minutes. This one doesn't need calculation, so as you don't have to do all VAN, you have to do R and A. That should be enough. Yes, Ella?
It should be C.
It should be C. So you're saying that median will decrease, however the mean will increase. Yeah? Okay. I will not ask you why. I will let everybody think through it and then you can tell me a story with that. Tony, going for the kill, right? Dave, you're clear with the question, right? Dave and Nikhil?
Yes, sir.
Okay. And Jenna, since you have completed this problem, I would suggest just review your answer, okay? just to be doubly, triply sure about whatever you concluded, okay? Yes, Neil, what did you get?
I think they're both gonna increase.
They are both going to increase? Okay.
Sir, I got A.
Both will increase? Yes, Syed?
I got A.
A as in both will increase, that's what you're saying?
Both will increase.
Okay, we'll see. So I'll give maybe 1 more minute and then I would want to hear from each one of you to understand what is the reason why you are leaning on or leaning towards an answer, okay?
Both will increase.
Both will increase, okay. Okay, so
I
Sai,
thought both will increase.
somebody also thinks so, okay. How about Kushi? What do you think, Beta?
I got A.
You also got A. How about Ananya? Dheera?
I also got A.
You also got A. Okay. What about Ria? Ria, I have not heard you for last 3-4 weeks. Courtesy the microphone. What do you want to say today?
I got A too.
You also got A. Wonderful. Okay. So it was Jenna who started first. So Jenna, tell me, Beta, what was your? You said I think option C. That's what I remember. So tell me what is the reasoning for it. And again, I'm not trying to prove anybody right or wrong. I'm just trying to read everybody's mind to understand how did you get to an answer. Jenna, you want to explain that, Beta?
Oh yeah. So maybe I did something wrong, but
No, it's okay. Again, you did something based on certain understanding. My goal is to not to get to the right or wrong answer. I'm just trying to see how you approached or got to that answer. And if there is some correction in it, that's what we are here for. That's fine.
okay. First I try to figure out the mean without like the extra
This thing.
crop or whatever.
Mm-hmm.
And then I included the crop to see if it increased,
Okay.
and it did.
Okay.
And then I went to look for the median, but I think I messed up there. It's like for median, I think the number that comes the most or something, right?
No, that is mode. Median is when you arrange them in the increasing order and then find the middle number. So here, whatever you had, okay, what was the number? The next one that we added, 57,000 something, right?
57 and 93.
How much? 57?
930.
30? Okay. So mean is straightforward. Look at this, 46,000, 75,000, 75,000, 53,000, 42,000. If I add them together, this is 150,000, 151,000 plus 46. 51 plus 46, 197 approximately. 196, and then this is adding up to close to 95. 196 to 195, almost 290,000 by 5. 290 by 5, if I do, that gives me 5 5 are 25, 4 5 58,000. No, I'm just trying to act super smart, and that's where I'm going wrong. Let me not do that. Let me add 0, 0, 0, 0, 0. 3 plus 3, 6 plus 3, 9. 5 plus 1, 6 plus 9, 15, 19. 1 carry forward. 2, 1 plus 2, 3 plus 3, 6 plus 5, 11 plus 5, 16 plus 6, 22. 2 carry forward. 2 plus 4, 6, 11, 18, 25, 29. Yeah, this divided by 5. 5 5 are 25, 22, 5 4 are 20, 22 9, 5 5 are 25, 4 9, 5 9 are 45, 4 0, 5 8 are 40. So 54,598, that is my average. That is my mean. If I am adding any number which is more than this, that will certainly increase my mean. So you are right with the first point, Jenna, okay? So, and everybody else, most of you gave me the answer is A. I'm just trying to validate that, okay? So, my mean for this existing number was 54,590. If I'm adding anything which is 57,000 or anything more than 54,598, then it will increase my mean for sure. So, mean is increasing for sure. Now the question was, what happens to the median? Because we have to do our assessment with respect to both of them. So my median would be like, okay, let's arrange them in the increasing order first. 56, 400, 70, then 53. Next is, no, this is my smallest is 42,000. 42, 530, 46, 400. That will not put a comma, that will confuse you guys. Smallest is this one, then this one, then this one. 53, 130. Next is 75,000. Next is 75,930. Now when I am trying to find out the median for this guy, that will be the middle number, 53,130. Okay? But we are adding one more, which is 57,930. So there will be a number here in the middle, 57,930. And now the number of elements I have from 5 became 6. So we will have to look at the third and fourth number and find out the average of that. My current median was this one. And I have added one more number, so the center becomes, this becomes a even number of elements. That means I'll have to take the middle two numbers and take the average of that. So 53,000, that was my earlier mean. Now my, median. Now my new median will be average of 53,000 and 57,000. That is also increasing, right? So that is the reason why my mean and median both will increase. Does that make sense to everybody? Jenna, do you agree with her? Yeah? So again, I would say one very lame, I'm sorry if I'm using bad words here, a very lame approach, sometimes I call it, right, for myself, not for you guys. You guys are smarter. Here would be if I have a number which is bigger than the mean, okay? Mean you have to anyway find. And if a number is bigger than the mean, there's a very high likelihood that your median will also increase, because mostly your median is closer to the mean. If there's a big difference between median and mean, then if you're correct, see, look at earlier set of numbers. When you had these 5 numbers, your average was somewhere around, what was the average? 52,000? 59,000? No, it was not 9,000. It was less than that. It was less than that. That's why we said, okay, my mean is also increasing. Right? Yeah? 54,000 something was there, that mean. I deleted that. So what I'm saying is, if my mean is closer to my median value, okay, unless there's a starking difference between our median and the mean, you can assume that when your mean increases, your median will also increase. But again, you'll have to validate that. Don't go by what I'm saying. That is not written in stone, okay? Let's not confuse much with this one. My only point here was that once you find out the mean and you find out the median, if you see that your mean and median are not very far from each other, then any number bigger than mean that you add will increase both of them for sake of simplicity. Okay? I don't know if I made enough sense to you guys or not, but this was a much simpler problem. It's just about not rushing to it. Okay, as long as you guys do it carefully, you'll be fine. Okay, but I hope everybody is clear with what we did, right? So these kind of problems will actually bother you guys during the exam, not because they are difficult to solve, but they have a lot of information, and your total effort will go only for decoding the information and deriving some conclusion out of it. Okay, so as long as you are ready to invest that time, you'll be fine. Tony, okay? Dave, Samriddhi, everybody clear, right? Kushi, Dhira, no concerns? Okay, cool. Let's move on. Let's go to the next problem. And you guys are okay doing the problems, right? I mean, I want you all to, kind of deal with the problems, get the flavor of the problems. It's not just about me telling, okay, this is how you find mean, median, mode, which you guys anyways knew. So what is that I'm doing here? I'm just trying to get you guys used to the kind of problems that you'll deal with, and how comfortably you're approaching them is what will make the difference. Let's go to the next problem. The area in thousands of square kilometers of 19 countries in East and South Asia are shown in the dot plot. Oopsie daisy, I did not put the dot plot. Okay, I have not taken the dot plot, but it's okay. Let's look at the question here. The area in thousands of square kilometers of 19 countries in East and Southeast Asia are shown in the dot plots. Each value is rounded to the nearest to 50,000. So we're talking about 19 countries, and now 19 countries in East and Southeast Asia. Each value is rounded to nearest 250,000 square kilometers. China, which has okay, let me pick up another question because I don't have the complete question here in front of me, and I'll get you guys confused for no good reason. Let's pick the next one. Okay, let's pick another problem, and then we will. So I have a table here again. It says birth weight of piglets in kilograms, and we have some information here. 0.98, 1.13, 1.16, 1.2, and then 1.25, 1.33, 1.36, 1.38, 1.44, 1.48, then 1.52, 1.66, 1.70, 1.73. Okay. These are the, whatever you see here on the board, these are birth weights of piglets in kilograms. So 0.98, 1.13, 1.16, 1.20, 1.25, 1.33, 1.36, 1.38, until 1.73. I'm not sure if you guys have noticed this so far or not, but these are the weights of piglets at the time of birth. And just by looking at the data, I see that whoever has given the data for this question, they have already arranged the order and the data in the increasing order. Okay. So this is not completely unorganized data, a little bit organized, okay? Let's move on. I'm just reading it again. The table lists the weights in kilograms of a litter of newborn piglets. Of the mean range, the standard deviation of the value listed which will decrease if the 0.98 kilogram measurement is removed from the data. So it says of the mean range and standard deviation of the value listed, which will decrease if the 0.98 kilogram measurement, if 0.98 kilogram measurement, if this one is removed, it says if this one is removed, the mean range and the standard deviation will reduce if this one is taken out from this information. Now you have to tell me whether this statement is true. Okay. No, sorry. So let me go from the beginning. These are the weights of the piglet given at the time of birth in kilograms. Then this says if 0.9 is taken out from this data, what all will decrease? Okay, that's a summary of it. I'm reading the question one more time. It says of the mean range and standard deviation of the value listed, which will decrease if 0.98 is taken out from this data. So of the mean range and standard deviation, what will decrease if this one is taken out? Of the mean, range and standard deviation of the value listed, which will decrease if 0.98 kilogram measurement is removed from the data. The question is, we have to choose between mean, range and standard deviation. Now you guys must be thinking, we are not talking about standard deviation. We'll come to that one, okay? I probably skipped that. We did not talk about that. Of the mean, range and standard deviation, what will decrease if 0.98 is taken out from the data? And then the options you have are option A says only mean will decrease. If you take 0.98 out from this data, only mean will decrease. Option B says only range will decrease. So we have to find out which all will decrease, okay? So option A says only mean will decrease. Option B says only range will decrease. Option C says range and standard deviation only. So range and standard deviation will decrease. And the option D says mean, range and standard deviation. So mean, range and standard deviation. So we have not touched upon standard deviation. We'll come to that, but let's see who all knows about it. From this question, these were the details that were given to us, saying these are the weights of the piglets, of the newborn piglets in kilograms. Then says if 0.98 is taken out from this one, what all will decrease from mean, range and standard deviation? The question was, what will decrease? Mean, range and standard deviation. You have to choose from these three. First option says only mean will decrease. Second option says only range will decrease. Third option says range and standard deviation will decrease. Option 4 says mean will decrease. Sorry, mean, range, standard deviation, all three will decrease. So now you have to tell me what will decrease. So you guys try to find out mean and range. Will come to standard deviation. If somebody knows about standard deviation, then probably we'll talk about that as well. Otherwise, I'll explain the standard deviation as another topic that I have not covered in the last couple of days. Are you guys clear about the question, or it is confusing as always? Did everybody hear the question? Samriddhi is okay, Nanya is okay, Jana is okay, Deera is okay, all right. Yeah, Dave?
Could you repeat it? It kind of cut out for me.
Okay. So, there is a table above, a box in which you have certain data, 5, 10, plus 14 data elements given to us, and these are the age of the newborn piglets. So there are 14 piglets for whom the weight is given to us in kilograms. Okay. Then the question says, If you take out 0.98 from this data, meaning if you exclude this from the data, what will decrease from mean, range and standard deviation? Meaning, if you are taking this thing out, what all will decrease? Obviously, when you have the entire data, you can find the mean and range from this data as well as standard deviation. Some of you might not know how to calculate it. I will explain that because I have not explained that yet. It says out of 14 records, you will find a mean, range and standard deviation. If you take this guy out, 0.98 out from the data, what all will decrease? Will your mean decrease? Will your range decrease? Will your standard deviation decrease? Will all decrease? And here are the options. First option says only mean will decrease. Second option says only range will decrease. Third option says range and standard deviation will decrease. Fourth option says mean, range, standard deviation, everything will decrease. Are you clear about the question, Dave?
Yeah, thanks.
Okay. Tony, there is a message for you. Your network wants you to be in the classroom with her. Your network keeps on glitching. Yeah? Yes, Jenna.
I think I have the answer.
Yep, go ahead, tell me.
So I know that range is
Huh.
decreasing,
Okay.
but I don't know what standard deviation is.
Standard deviation I have not taught recently, so I will explain that later. That's okay. But you are saying that range
I
will
think
decrease.
either B or C then.
Okay, how about mean? Will the mean decrease or no?
No.
Mean will not decrease, okay? So I can at least sense what you are thinking. I'll not let you talk about it though. I want everybody to think, but I think you are thinking the right direction. You are saying that your range will decrease and your mean will not decrease. Okay? Standard deviation will park it because I have to explain that to you guys. Okay. Anybody else? I'll give you guys maybe 2-3 minutes so that we can save last 15 minutes to calculate standard deviation.
I got C.
You got C. So you think that the range as well as standard deviation both will decrease?
Yeah.
Okay, we'll see. I'm not confirming Jenna or Samriddhi or anybody. I want everybody to give it a try. Don't trust your best friends also. So 3:43 is when I will request everybody to stop. Ananya, Tony, Dira, what's happening? Kushi? Yes, Ananya.
I got C.
You also got C. So you also know that range and standard deviation will decrease. Okay. Nikhil, what's up? Riya, how about you, beta?
I'm still working on it.
Still working on it? Okay. So, it's okay, beta. So, Riya's problem is transferred to Nikhil now. Earlier, Riya's mic was not working, now Nikhil's mic is not working. So, there's one child in the class always who has problem with the mic. Sure.
Let's see.
You also think C? Sahit, Arush, what's up? What do you think is the right answer?
I think it's C.
You also think C? Ritika, how about you? Yes, Sahit, go ahead.
I think it's also C.
Okay. Yes, Dave.
I also got C.
You also got C. Okay. Ritika?
I'm still thinking, but I don't really remember like the standard deviation was though.
Okay.
Not like 100% sure.
Okay. How about Neil and Sarah?
I'm still thinking.
Thinking. You also got C. Okay. Saranya and Viswa?
I'm still thinking about it.
Okay. So,
Just sir.
I'm sorry, Vika?
I'm still thinking.
Okay. Alright, so probably I'm not trying to halt everybody's thought process, but we'll probably use the remaining 15 minutes to dig into something that I had not covered in the previous classes, that is standard deviation. So, without touching the standard deviation, okay, let's look at what all will change. I will not talk about standard deviation at least for now, unless we come to this one. We'll talk about mean and range first. What is mean? Mean is the average of everything. Since this is an increasing order and we're talking about the smallest number, when I'm taking the smallest number out, my mean or my average will increase. See, so mean is not decreasing. So any option which talks about mean decreasing, that is not true in this case. Because when I'm taking the smallest number out, right, this is increasing order. This is the highest, this is the smallest. So when you're taking the smallest number out, your mean is actually increasing, not decreasing. So that is out of question. Okay. Now, is my range increasing or decreasing? My range is from the smallest number to the largest number, the difference between the two. So 0.98, if that is taken out, let me do that in the simplest possible way. In the earlier circumstances when we had 0.98, what is my range? Range is the difference between the smallest number and the largest number. So 1.73 minus 0.98. That will give me 5 and 6. No, 73, 75, sorry. 175. This is my difference. This is my range. If I take this guy out, then my range would be a difference of this and this. 1.13. So this became 0.6. Without doing this calculation also you can find it out. Your range is always the difference between the smallest and the largest number. When you take out the smallest number, you are bridging the gap between the smallest and the largest number basically. Yeah. So your range is decreasing. Earlier the range was bigger. You took the smallest number out, so they have come closer. So the gap is reduced and your range has decreased. Yeah. So range and mean. Mean is increasing, range is decreasing. So mean decreasing is out of question. Mean, range and standard deviation, this is also out of question. So we are left with only range and standard deviation. Yep.
Would the standard deviation decreasing because when you take out another like far outlier, your deviation between the different
Is also reducing. Yeah. So because some of the kids have not dealt with standard deviation recently, so that's why I'm not talking about it, but you're right with the assessment, okay? Now, if somebody has to tell me what is standard deviation, what is your understanding of standard deviation? What do you mean by standard deviation? What is deviation? Yeah.
the amount of like difference
Change.
change
Yeah.
and, like this different points.
So let's, yes, Dave.
It could be like the change between what's considered like normal and one
Right.
deviation could be like plus from a normal.
Right. So here's the thing.
Let me put some numbers here. I will put 2 examples and then we'll solve it, okay? I have 4 data points. Let's say 2 sets of data. My first set of data is 2, 5, 1 and 7. My second set of data is 3, 19, 8, 27. If you look at this record, this set of data, it changed by 3, second one, if you look at the difference between these numbers, 2 to 5, 5 to 1, 1 to 7, in the range of single digit. Here if you look, the difference between 3 and 19 is 16. 19 and 8 is around 11. 8 and 27 is again 19. We are seeing much more variation in the numbers or the values compared to this one. When there are a lot of variance, that is what we mean by deviation, right? If I deviate a lot, let's say I am teaching you algebra and then I jump onto trigonometry, there is a small deviation, but we are within the boundaries of math. If I'm teaching you as trigonometry and then I start talking about neural network, there's a lot of deviation, there's no correlation, there's a huge gap between the topic and something that is being discussed. So when you see a lot of deviation between the data that we are dealing with, there's a method to the madness. And that is where we use the technique called standard deviation. So the standard deviation helps us find a interesting way to solve the problem. So I'll keep the door open for now. Okay? So standard deviation. No, you sit down. No closing the door. You have a jacket, right? Put it on. Yeah. After your class starts, I'll close it. Okay. So standard deviation actually, see, here we are seeing a lot of less variance. Here we are seeing huge variance. So that variance is measured by a technique called standard deviation, and we'll use the technique to figure out how do you measure that. This data could be different from this one, but there's one method that will help us find out what is the variance. Is it having more variance or is it having more variance? And that will be based on standard deviation. If the standard deviation is more, variance is more. Standard deviation is less, variance is less. Let's look at how do you find out the standard deviation. So the method to that is, I will say standard deviation, let's say if I call it standard deviation is equal to square root of x1 minus, this space is not enough. Standard deviation D is equal to sum of x1 minus mean square divided by n. Yeah. Now some interesting thing that you are seeing. Don't get confused about it. This n is nothing but the mean of whatever data you're looking at. And then what you're doing here is every number you are comparing against the mean and doing a square of that and adding all of them. So first number, subtract the mean from it, whatever you get, do a square of that. Second number, subtract the mean from it, do a square of that. Keep adding it till the last number, and once you get all the number, divide that by n, meaning number of elements you had, and then get a square root of that. So basically, even if this formula looks cryptic, don't worry about it. Ultimately what we'll do is, we'll find out this data set that we're looking at, find out the mean of it, and then subtract the mean from every number. Whatever you get, do a square of that, add them up, divide that by how many elements you had in the data set, and then do a square root of that. So this is more like a technique that tells you how much is the deviation here, how much is the standard deviation here. Optically, we can see that we have much more deviation in the second set of records. Here we have less deviation, but we'll find it out mathematically, and then we'll deal with it. So here, what is my mean? 2 plus 5, 7 plus 1, 8 plus 7, 15. 15 divided by 4, that is 3.75. This is my mean. So what I'll do is, look at first number, 2 minus 3.75, do a square of that. Second number, 5 minus 3.75, do a square of that. Plus 1 minus 3.75, do a square of that. 10, 7 minus 3.75, do a square of that. Okay, let's see how much we got. 2 minus 3.75, 1.75. So minus 1.75 square of that. 5 minus 3.75, that is 1.25 square of that. Plus 1 minus 3.75, that is minus 2.75. Do a square of that. Plus 7 minus 3.75. So this will be 3.25 square of that. Let's add them together. This will be close to 4. It will be 3, let's say 3.6. Okay. And this will be 1.25. So it will be close to 1.4. Okay. I'm just rounding it to the nearest number that you can calculate. And minus square will give you a plus value only. Okay. 2.75. It will be somewhere around 6.2 types. Okay. I'm just rounding it. 3.25. It will be somewhere around 10. So what we got? 3.6 plus 1.45. 611 plus 10, 21. 21. Then you divide that by how many terms we had? 4. And do a square root of that. So 21 by 4 is like 6.25. Square root of that, it will be 2.25. 5.25. Yeah. So 5, yeah, somewhere around 2.25 or something like that. Okay, 2.1 maybe. So here what I did, if you guys recollect, we took the numbers, found out the mean of that, and then every number, we are subtracting the mean from every number and doing a square of that. And then we added them together. Whatever value we got, divided that by how many terms we had. 1, 2, 3, 4, divided by that, and got a square root of that. So in the beginning, you took the difference and did a square, added them together. At the end, you do a square root. Okay. So all the kids from level 1 have joined early. Don't worry about it. Whatever you are seeing on the board, that is not to get you guys worried. Okay. Halloween is over, so don't get haunted by this. You guys will learn when you guys grow up a little bit more. We'll start your class in another 5-6 months from now. So we got the standard deviation for the first one is 2.25. Now let's look at this thing. Same way we'll do. 28, 7 plus 8, 35 plus 338, 9, 47 plus 10, 57. So now what we'll do is 3 minus 57 square plus 19 minus 57 square plus 8 minus 57 square plus 27 minus 57. Oops, what did I do? Your class is starting for this. Come on. So, sorry, I did something mistake. I did a mistake. So these 4 numbers divided by 4, that's what will be my mean. So it will be like 19, 4 plus, yeah. So 15, 7, 4 1 is 4, 14, yeah, 14. So now 3 minus 14 square, 19 minus 14 square, 8 minus 14 square, and then 27 minus 14 squared. Okay. So here 3 minus 14, 11 squared, 121. Plus 19 minus 14, 5 squared, 25. 8 minus 14 is 6 squared, 36. Plus 27 minus 14 is 13 squared, 169. So when you add them together, this becomes 1 plus 5, 6, plus 6, 12, plus 9, 21, 2, plus 2, 4, plus 2, 6, plus 3, 9, plus 6, 15, 1, plus 1, 2, plus 1, 3. 351 divide by 4 because you have 4 elements and do a square root of that. What you will get here is going to be somewhere close to 99 or 100. Square root of that will give you a 10. Look at this standard deviation 2.25 and look at the standard deviation 10. This was regardless of how many elements you have in the data set that you are dealing with. This gives you a very clear point blank view into how much is the deviation and a mathematical way to look at it. So summary of that is standard deviation is a standard way to find out the variance in the data that you are dealing with. Are your data elements fluctuating a lot? Is there a huge difference or is there less difference? So this becomes a tool that we will use for finding out how much your data elements are wavering. Guys, don't keep making your pencil, eraser, yourself allowed to fall, okay? Alright? Hold your pants tight. If that falls, that's the bigger problem. Yeah? Alright. So, for all of you who are coming across standard deviation for the first time, this is a tool that gives us a mathematical way to find out how much is the variance in the data that we're dealing with. And the simple method to the madness is you take all the data elements, find out the average of that will be a mean, then every number, subtract the mean from every number, get the difference, do a square of that, add them together, then divide that by how many elements you had, and then the square root. Okay? So, I know it might be something that came very quick with less time, but watch the video of the class, try picking up some random sample of data, try doing standard deviation of that, and don't try to solve it to get a standard deviation. Create some sample data elements, one with lot of variance, one with less variance, and see is your standard deviation giving you the right view or not. So with the problem that we are dealing with, it was saying that will my standard deviation decrease? Yeah, it will decrease because your mean is decreasing. Your mean becoming smaller. That means the difference between every number and the mean will change.
The mean is increasing.
Mean is increasing. So if mean is increasing, then you will, okay, let me not make a judgment here. I'll go by what you guys interpret by doing this one more time and then pick up some sample data and try finding out standard deviation. For the same problem that we were trying to solve, just validate it one more time by removing the first data record, which was the smallest of all, and then see what happens. Okay? Did I complicate it or it was easy to follow?